Hello everyone, my name is Dr. Arshad Iqbal. Today we will learn about artificial intelligence, machine learning, deep learning, and data science. Sometimes it creates a bit confusion. What is the difference between artificial intelligence and data science, and how machine learning and deep learning affect artificial intelligence based system? So we will learn that in a bit detail. So let's go with artificial intelligence. First, what is artificial intelligence? So artificial intelligence is the intelligence demonstrated by machine as compared to the intelligence demonstrated by human or animal. So the main purpose of artificial intelligence is to make machine as intelligence as to carry out the usual tasks carried out by human beings or maybe animals. So that's artificial intelligence. So let's go with some basic definition. So artificial intelligence is the theory and development of computer systems to perform tasks usually carried out by human being. Uh, so, uh, so, so there are two things in artificial intelligence. One is theory, and one is development of computer systems. So, how theory affects computer systems? So, actually, the concept behind smart machine is the analytical models used for computer system to do such tasks, and then based on that theoretical models, some systems are developed or some applications are developed to perform that task, usually carried out by human beings, or in another words, simulation of human intelligence processes by machine, especially computer system. So actually the demonstration of human intelligence processed by machine, especially computer systems, is called artificial intelligence. So let's see a few example of AI. So there is a kind of network of social network of people or network of computer. So there could be seen that analytical results are shown through a smart screen, and which is connected through a cloud network, in different walk of different people of different walk of life actually use that analytics for their own system. For example, doctor could use that analytics for patients cure, or industrial system could use that data for data analytics of industry. And a common people can see different things based on that smart network. And there in the picture number 2, a lady is seen to be use dashboards or computer system to analyze some industry, and based on that it could extract some meaningful information. And the industry is actually artificial intelligence based industry. And the third one is quite interesting example in which a robot is actually folding and unfolding a cloth or a towel. So which is very interesting, because if robot could be used to carry out that kind of task which is usually carried out by human beings. So actually this is the a real example of artificial intelligence based system or robot. So let's see some more applications of AI in different industries. First is manufacturing robots. So robot could be used in industry to use for different manufacturing systems. So in the this infographics, a robot is actually manufacture some some blocks which is quite interesting. And there is self-driving cars. So a driver is sitting in the car, but he is not driving. He is just experiencing the how the car is actually drives. So if you see drive the car usually pass through a normal road, but it also passes to some hurdle. So according to that hurdles, the speed of the car actually reduces. Quite interesting example of self-driving cars or smart self-driving cars based on artificial intelligence. And then there is smart assistance. So it helps human to carry out their usual activity. For example, managing their calendar, managing their study or graduation, managing their books, and all are connected through a cloud. It could make some decision. It could make some decision based on that analytics. So actually, a smart AI based network system is actually assisting a human being to carry out usual activity. And then another very nice example of that is proactive health management. So if you could see doctors actually analyzing patient data through a system. For example, a CT scan machine is when a patient is examined through a CT scan machine, then a doctor can examine their CT scan on some kind of tablet. And different doctor sitting in different area could see that analytics on their screen and give the useful input. And common people can also see the result of different tests on different computer. So quite interesting example of artificial intelligence. Some more example of the applications of AI. So disease mapping. Actually, we know that COVID-19 is actually very serious viral disease which damages human lungs and human internal organs. So AI based system could analyze X-ray of patient and give some meaningful info to a doctor sitting remotely. So the most critical thing in COVID-19 patient is the spreading of the virus. So during that situation, if some remote AI based remote system is used to analyze X-ray, so it can be used to slow down the spread of COVID-19. And some AI based algorithms could extract that meaningful information. And another interesting example of AI is automated financial investing. So we can see some robot or bot actually help human being to make decision based on the data available of the stock markets. So actually the bot or the robot is actually programming program which carried out usual activity. So it helps human being to take decision based on the available data. So it analyze the past data and the trend of the market and give some meaningful information to human being, and based on that analytics, a human could get some good decision to get benefit from the investment. Some more example to see a big picture of AI in different fields. Virtual travel booking agent could be a smart machine, so it could help in booking, pre-arrival, stay, checkout, operations. So all this data could be analyzed to a smart AI system. And then another very interesting example of artificial intelligence is social media monitoring. So social media could be monitored through smart artificial intelligence system. So it gives you some analysis or sentimental analysis. So like that post is positive, neutral, and negative. How much person is that positive, neutral, and negative? How many people reacted negatively? How many people reacted positively? And how many people were actually neutral? So businesses could use that the sentiments of people for their businesses of different social media platform. So and it could analyze the reaction of people and engagement of people to get to engage targeted people for their advertisements. So social media could be used for targeted advertisement to find the person who actually needs that product. So that could kind of application could be provided by AI based machines. So let's come to the machine learning. So let's see to formal definition of machine learning. First definition is provided by Arthur Samuel, which says the field of study, machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. This is an older and informal definition. So like giving computer the ability to learn without being explicitly programmed, what does it mean? So we don't need to program the computer each time to make a decision, but we make the computer able to take decision as the situation changes. So this is actually the formal definition provided by Arthur Samuel about the machine learning. And then another definition provided by Tom Mitchell: a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks in T is measured by performance parameter P improves with experience E, then it is called machine learning. So if some task is performed by some system, and the performance of that system could be improved with experience to get some meaningful results, is actually the machine learning or learning of a computer system or a machine. So for example, this is an example of checker game. So in this we see that there are two players, one is black and another is white. So we are in this game, experience is the playing many games of checkers, so by computers. Actually this is experience, and then T in this checker game is the task of playing checkers, carried out different steps, and P is the probability that the program will win the next game. So this is performance is the probability that the program will win the next game. So this is the an example of checker game according to the definition of Tom Mitchell. So let's study more about machine learning. Machine learning is actually the study of computer algorithm that can improve automatically through experience by the use of data, or a type of artificial intelligence. So machine learning is actually a type of artificial intelligence that allows software applications to become more accurate at predicting outcomes without being explicitly programmed. So the more focus is on the word explicitly programmed, without explicitly programmed. So actually learn or making machine intelligence is learning of machine. So there are two examples of machine learning is given for on the right. there is a AI based machine learning system where machine learns the incoming picture is either of a dog or either it is a cat. So first it is programmed by giving different pictures of dog and cat, and when the computer system is learn or train on based on that data, then when we give different picture to this system, so it check either this is the picture is of a dog or a cat. So it is quite interesting system. In another example, we see that this is the simulation of a smart city where we check the quality of life, cash inflow, outflow, consumer good profit, and daily wages. So the red is hospital, the blue is equipment firm, the light blue is food firm and raw material firm. So it's a kind of industrial event which is actually monitor different things of use or utilize in the industry. So the important thing is checking the quality of life through a dashboard. So if some changes happen in cash flow and daily wages, so it's a kind of checking the economic model of a city or of an area, how much consumer good profit is achieved, and what is the daily wages and how it changes with time. So actually that could be provided by the learning of machines through training, and then applying that training machine learning on the machine learn through training data on the normal life. So it's kind of quite interesting example. There are different types of learning. For example, supervised learning, unsupervised learning, reinforcement learning. So supervised learning is the learning with a supervisor or a teacher, and it is actually a task driven which predicts the next value. So there are three things: it learns through a supervisor or a teacher, it is a task driven, and third is it predicts next value. And then unsupervised learning, it is learning from pattern, and it is data driven, and it identify cluster in data. So this is unsupervised learning. And then reinforcement learning. Reinforcement learning is the learning through experiences or learn from mistakes. So it's a kind of natural phenomena where we human learn from our mistakes and go ahead with that experience to get benefit next time. So similar concept could be applied in machines to learn from the mistakes and use that experience for getting good results. So supervised learning is a type of machine learning which is task driven and which predict next value, and unsupervised learning is data driven, and it identify different cluster. So it is actually predict next value, it identify cluster. And reinforcement learning is to learn from mistakes, which is a kind of natural human nature phenomena, to use that in a system, robot, or machine. Let's learn supervised learning in a bit detail. Supervised learning is the machine learning. It is a task of learning the function and use function that maps an input to output based on example input output pairs. So it is actually learning with a teacher, task driven, and predict data. So machine learning algorithm or machine learning type which use through a supervisor and task driven and predict different data. So let's explain this with some example. For example, this is your data or clean data set. So first we split that into training data and test data, and then based on training data we train a model. When we train a model, data is split into two training and then train model, and then some score is derived from this trained model, and then score is used to evaluate the model to get different results. So this is very nice example of supervised learning. So what it does, like it first train data. So train data means learning with some supervisor. So we supervise the machine to learn this way, and then we give them to this training data, we give them to do some task, and then we give some test data to predict next value or predict some meaningful data from that test data or evaluate data of evaluation. Here is another example, and with strawberry, there are different sizes of strawberry are given to a machine and it predicts the size of strawberry. So for example, the size of this strawberry is 8 centimeters. So there are two 3, 5 and 8 centimeter data. So the size of this strawberry is 2 centimeter, the size of this strawberry is 5 centimeter, and the size of this strawberry is 8 centimeter. So it is predicted based on a supervised learning algorithm trained by a supervisor with training data and task of predicting the size of strawberry is given, which predict the next value or predict the size of next strawberry. So this is supervised learning. Another example of supervised learning is we divide supervised learning into classification and regression. So what is classification? So when the output variable is category, for example, it's a cat or it's a dog, or there is a disease or no disease, cancer disease or no disease, then it is classification. And regression, when the output variable is a real value, so it's, for example, dollar or weight, so then it is regression problem. So let's see an example of classification. For example, supervised machine learning. So there are dog and there are cat. So data is labeled, said that this picture belongs to dog category and these pictures belongs to cat category. And based on this label data, model is trained or label data is given to a machine. So whenever some input is given to that machine model, so it predicts that these pictures are of cat and these pictures are of dog. So this is supervised machine learning. And then a regression example. So regression is actually the output of finding a function for real value. So for example, these red dots, what kind of function could be used that it covers all this kind of data. So in future, when some data is given to that system and it is in that function, in the limitation of that function, so it could be used as our regression model. In another example, the regression model, actually the complex regression model, where data is changed, so the plot also changes with that. So it's a kind of real value output variable or real value output function. Unsupervised learning. Unsupervised learning is the use of AI algorithms to identify patterns in data sets containing data points that are neither classified nor labeled. So there is no labeling or there is no teacher, and there is no task driven, and there is no next value prediction. The thing is, it learns from different pattern, data driven, and identify cluster. So let's come with this example. So there are some data of different color of boxes are given to this algorithms, and this algorithm actually divide these boxes into different color. So raw data is given to algorithm, and it actually divided that algorithm using different function to red, yellow, and clustering red, yellow, blue, and gray area. So different cluster are made by that unsupervised machine learning algorithm. And there is another plot where different emojis are classified, and the cluster is made based on their shape. So and the emojis of different moods, so based on the mood and color, it is classified by unsupervised machine learning algorithm. Unsupervised learning is actually categorized as into clustering and association. So what is clustering? Clustering is when we want to discover the inherent groupings in the data. So cluster based on some inherent groupings in the data, and then we cluster them together. For example, male are clustered together, female are clustered together, dogs are clustered together. So like for example, grouping customers by purchasing behavior. For example, customer in different category by this, by clothes, by food items, by furniture, etc. And then association, when we want to discover rules that describe large portions of your data. For example, people that buy X also tend to buy. So it's a kind of association. And for example, a person which buy some item also buy another item. So let's explain that with example. For example, this is there are different classes of animal. So first classification, we classify that this is animal class, and then different animal class. For example, this is dog, this is goat, this is hen or chicken, and this is rabbit, etc. And based on different behavior, they are clustered together. These are bird and these are animal, so they are clustered together. And this is example of clustering. And there is another example on the left that for example, different people, when they buy toothpaste, so they may also buy toothbrush, and maybe some towel, because when you wash your teeth you might need a towel too. So this is actually association behavior. And then for example, people who buy egg and milk might also need to buy some cookies, because when you use in breakfast, some people use cookies also. So that's a kind of association behavior of unsupervised learning. So now let's explain reinforcement learning. Reinforcement learning is the training of machine learning models to make a sequence of decision. The agent learns to achieve a goal in an uncertain, potentially complex environment through different mistakes, through experience. So what is sequence of decision? Sequence of decision actually is taking decision and get some result. Either the result is positive or a negative, and from that positive or negative you extract some meaningful information. And then agent learns to achieve a goal. So agent has some certain goal in an uncertain, potentially complex environment. So an agent need to learn the best path or the best way to reach to achieve that goal. So for example, the enforcement learning environment actually, the concept is dependent on two things. One is environment and another is reinforcement learning agent. The environment is actually the state of the agent or different state in which reinforcement learning agent could act or could stay, and then action of agent and then reward based on that action. So what does reinforcement learning agent take some action and environment with some states and some rewards. So if the decision of reinforcement learning agent RL agent is good, so reward is positive. If that is bad or negative, then the result is negative. So let's see this example. For example, this rewards wants to reach to this flags, so winning position. So at first it starts, goes right, then it learns that it is not a good way, because if you go upside then there is some hurdle. So it take back and take decision at beginning to go up first. So then that way it reaches to its destination. In another way, if it doesn't learn, then it could reach to the destruction of itself. So this is actually reinforcement learning from mistake, learning from experiences, and model and train and use that experiences to get good result, positive rewards. Some more example about reinforcement learning. Learn how to behave successfully to achieve a goal while interacting with an external environment. Learn where via experiences. For example, game playing, player knows whether it win or lose, but not know how to move it each step. So this is quite popular application in earlier computers. So that is actually a reinforcement learning based example in which you don't know where is bomb, but the system don't know how to move it each step, and player knows whether it win or lose based on experiences. And there is another control system, traffic control system. A traffic control system can measure the delay of cars but not know how to decrease it. So this kind of mechanism could be learned through reinforcement learning algorithm, to learn from experiences and learn, for example, in traffic system, learn the delay of cars and learn how to decrease the delay, and in the game learn how to move or how to win or how to win the game. No, so let's study what is deep learning. Deep learning is machine learning technique that teaches computers to do what comes naturally to humans. So it is actually learned by example. So deep learning is actually learned by example, or teaches computer to do what comes naturally. For example, a computer model learns to perform classification tasks directly from images, text, or sound. So there are two examples. One is same example as dog and cat. So in deep learning there are different layers: input layer, hidden layer, and output layer. So when an input is given, it passes through hidden, through different activation function, and based on that output could be achieved. For example, input is given of a dog, so it passes through input layer we give dog, and then passing through hidden layer, and then it gives the result of dog. So this is actually an example of deep learning. So using deep layers. There is another very interesting example. When you give some text image, it passes through input layer and two hidden layers. There are two hidden layers. Hidden layers could be one or more, and then there is output layer. So this system actually classify the input of a text image. So for example, when text image is given 7, so it passes through input layer, hidden layer, and it extracts some meaningful information at each layer, and in the end the system predict that this is number 7. That's quite interesting example of deep learning. Some more about deep learning. Deep learning also called representation learning. So it's actually learn different feature or learn different representation. It seeks to learn rich hierarchical features automatically using multiple feature learning processes. So here it involves multiple or complex feature learning processes. There are different examples we can find. For example, Siri, Alexa, Cortana, translation, Google Translator. If you have used, for example, English to Chinese language and Chinese language to English, Urdu to English and English to Urdu, and so on. And it provides vision for driverless delivery trucks. Deep learning provide vision for driverless delivery trucks, drones, and autonomous cars. That's a quite interesting application of deep learning. So in this example, a system classified different object programs, the car, vehicles, small cars, and some red and green examples. So the targeted example is red or green. What is deep learning? Some more application of deep learning. So there are chatbots and service bots. For example, this example provides some chatbots and service bot. For example, it communicates with human being. Hi Jagat, welcome to LNT Construction. Say hi, and to bot HR. And this bot is artificial intelligence and natural language processing base which interact with human being. And then image classification. So some kind of facial recognition protocols are used to differentiate different person. For example, here their example, different humans and their age, height, eye color, hair color, and different information of that person is saved in the database, and learn through that learning deep learning algorithms what is the color of that person, what is the height, what is the weight, what is the hair color. So all this kind of information is derived from this image of that person. So this is actually image colorization, or image colorization is different concept. This is actually facial recognition. And then deep learning example can be found in medicine and pharmaceuticals. For example, learning different patterns or different feature in a medicine, or formula of medicine, or behavior of medicine, and personalized shopping and entertainment could be targeted through deep learning to find the behavior of buying behavior of a person, and based on that targeted advertisement could be done. So, and what kind of entertainment is the habit or the behavior of the person. So based on that result, or for example in YouTube we can see that or Facebook we usually see a news feed, or which is our interest. For example, politics, entertainment, and when we see some movie or listen some song or watch some song, then based on that result, the remaining result we see on our newsfeed or on our screen is related to that song or that movie. That's the application of deep learning. No, what is data science? Data science is the field of study that combines domain expertise to extract meaningful insights from data. So this is actually extracting meaningful data from data is data science. So the science of data, play with the data, and extracting information from the data is data science. So it actually requires two skills. One is programming skill, for example, Python, MATLAB, C Sharp, and knowledge of mathematics and statistics. Yes, we know that there are statistic is the main, or mathematics is the main concept behind the analytics. So there are two examples. One is on the left, there is a dashboard of some industrial system, and a person actually monitor that on real time. The data is feed to different system, and it check the industrial system on real-time based data, and it can take decision based on that analytics. And on another side, this dashboard is provided for voice data or call data or complaint call center. For example, average talk is 25 minutes, 13 minutes, 17 minutes. Call drivers, product A, product B, complain, how many bugs, what is the billing, and competitor mentions Xfinity, Warner, Direct TV, and average CSAT score, average NPST score, first call resolution, on hold, on transfer, abandoned calls, call escalation, sales of product could be checked live, and sales by agent. So it's quite interesting, and data analytics are provided through dashboard using data science technique, data science algorithm. So this is an example of data science. So there are usually 5 steps involved in data science. Unstructured data is the first step. You have some unstructured data about which you don't know what could be what is in that data. So first, after one unstructured data, first step is to sort that data. So first unstructured data, and then data is sorted based on color, and then the data is arranged according to their shape or their model, and then presented visually that black are that much, green, yellow, and blue, red. These are visually presented, and then explained with a story. So this is actually the final result, extracting meaningful information from that, and or explaining that data with a story. So the story is in this last picture. So there are 4 major steps other than unstructured data. So if you have unstructured data, then there are 4 steps: data sorting, data arrangement, visual representation, and explaining a story. And these are 4 major steps of data science. And this is not that easy. There are much algorithms required, much programming required, and much statistic and mathematics required to go from step 1 to step 5. So for example, statistical technique, mathematical formulation, and of course programming skills to explain all this data with a story. So there are 3 kind of data. One is small data, where the data size is less than 10 GB or 10 gigabyte. And then there is medium data, where the data is between the data size or memory size. Memory is between 10 gigabyte to 1 terabyte, and big data is more than 1 terabyte. So actually this table explain different data with different category. Class is small, medium, big. Data size is less than 10 GB, and medium is 10 GB to 1 TB, and more data than 1 TB is big data. How to manage that data? When small data, you can manage with Excel or R, and medium is good monolithic databases, and big data Hadoop distributed database systems. How it fits in one machine's memory. Small data, medium data fits on one machine's disk, and big data stores across many machines. Example, thousands of sales figure is actually small data, millions of web pages is medium data, and billions of web clicks is big data. So this example, first the data is this much, now the data is that much, very powerful image. So it requires more algorithm, more resources to manage, and more resources to store. And this is an example of big data. So there are social media platform which the data is feed through different social media platform, and the result of that social media platform is shown through a dashboard. Behind this screen there are a lot of efforts required to get these kind of meaningful information. For example, Google information, LinkedIn information, Google Plus, Twitter, Facebook, and the data is all shown through a dashboard. Big data example. Facebook generates 4 petabytes of data per day. What is petabyte? Petabyte is 10 raised to the power 15. It's actually peta, quadrillion. That's a million gigabytes. Google processes 24 petabytes per day. Huge sum of data. And IBM creates 2.5 exabyte per day. Exabyte is 10 raised to the power 18. So let's learn about 4 key characteristics of big data: volume, veracity, velocity, and variety. Volume is 1 petabyte, and 1 petabyte contain 1024 terabytes. Insight, quality and value is actually veracity, and velocity is frequency of generation and processes on real time, and variety is type and nature of big data. These are 4 key characteristics of big data. And Facebook logo makes so much sense now. So everyone is busy lying their head down and watching different stuff on Facebook, and become a part of 4 petabytes of data per day. Big picture all in one. So this is a picture of artificial intelligence, machine learning, deep learning, and data science all in one. So actually artificial intelligence is the big ball, and then within that ball there is like a machine learning ball. So actually machine learning is a set of machine learning, and deep learning is a subset of machine learning, and of course artificial intelligence. And data science actually lies half in the deep learning and machine learning and artificial intelligence, but half lies in statistical model, mathematical model, and data visualization is the main concept of data science. So maths and statistic visualization, EDA. Let's read it in a bit detail. So artificial intelligence is actually generalized idea of thinking machine. This is the summarized definition of artificial intelligence. Machine learning is making data-driven prediction. So models are trained and based on some data skills and based on that some decisions prediction could be taken. Deep learning is the class of state-of-the-art machine learning algorithm which learn different feature, micro feature of the data, and based on that decision is taken. While data science is applied machine learning as statistics for data analysis and prediction. So this is actually data science all in one picture. So if you could see artificial intelligence as the main pillar, then machine learning, then deep learning, and partially data science, and remaining part of data science is maths and statistics and visualization of data. So this is big picture of all in one concept. That's all for today. Stay tuned for more informative contents. Please leave your comments or queries. I will try my best to respond at the earliest. And please like, share, and subscribe this channel. See you in next video. Good luck. Good wishes.